it is. So question 2, the diagram shows the activity network for a project. The figures in brackets show the durations of the activities in hours. So slightly unusually, we're given the network diagram before we start. We're not starting from the precedence table, we're starting from this, which is slightly unusual. So make sure that we are confident in going from precedence table to this diagram. But anyway, complete the table in your answer to show the immediate predecessors for each activity, and then carry out a forward pass and a backward pass on the copy of the network in your answer book, showing the early event times and late event times. State the minimum project completion time in hours, and list the critical activities. I'm just going to do a little bit of highlighting in here, because actually I found that there was a lot going on, wasn't there, in this one little part 2 of the question. And unfortunately quite a few of us missed some of the extra things. So the big headline thing is do the forward pass and backward pass, but then it does say state the minimum completion time. So it's got to be not just in your answer, it's going to be a separate statement, and list the critical activities. So that was missed by a few of us. So I think we can do it straight from here, can't we? A and B have no immediate predecessors. You need to show that by marking in the box that there are no immediate predecessors. C, according to that, relies upon B. D relies upon A, and A only. But E looks to rely upon both A and B. F depends upon C being complete. G depends upon C being complete. And H depends upon, what have we got there? G and F. Hang on, I'm looking at the wrong thing there. H, sorry, depends upon D and E. There we are. Okay. I just momentarily got into a mind there that, there's the other way of doing it, isn't there, where you do the activities as the nodes instead of the arcs, which is the way that we do it with our use of math students. So I've got to make sure that I'm concentrating on which way around I'm doing this. Right, then we're supposed to do our forward and backward scan. So that's right, I think they just gave 2 marks for that first bit. Forward and backward scan. So we're going to start by putting 0 in there. And then remember, it's the earliest time that all the preceding activities have finished. That's the earliest event time. So that is going to be a 4. And that one's going to be a 5. Now as we work our way through this, C only depends on this depends on C having completed, and that would complete after 9, because we're doing 5 plus the 4. This here, we've got, we need to have both that one and that one completed for this event to start. Well, that means it's got to be the later time. We can't put 4 there, because that one wouldn't have completed, so that has to be a 5 in that box. We're then moving on to this box here. We need D and E. So E, 5 plus 4 is 9, 4 plus 2 is 6. We need to take the later of those 2 times, so we're going to put a 9 in there. In this box we've got 9 plus the 2 would be 11. And here we're doing 11 plus 0, 9 plus 3, so 11 plus 0 is 11. 9 plus 3 is 12, 9 plus 4 is 13. We need all of those things to have happened, so that must be 13 in that box. Then when we do the backwards scan, we do start by writing 13 there, and now work our way backwards. 13 take 4 is 9, 13 take 0 is 13, 13 take 3 is 10, and 13 take 2 is 11. Now on the way back we're choosing the smallest one, so that's going to be a 10. And our logic there is thinking that if we delay any later than 10, we wouldn't have time for these 3 hours to take place before we get to 13. So that's our reasoning behind that one. 9 take 4 is 5. 5 take away 0 and 9 take away 2. We choose the smaller of those two values, so that's going to be 5 in there. 10 take away 4 is 6. 5 take away 0 is 5. Choose the smaller, which is 5. And 5 take away 5 is 0. 5 take away 4 is 1. Choose the smaller, which is 0. And that's that done. But the question did say, stating your completion time. Was that how they said it? Wrong question. State the minimum project completion time. So the time is 13 hours. List the critical activities. So critical activities are one where any delay would affect these numbers here. If we're looking through this, we can see that that one, B, is critical, because 0 plus 5 is 5. What else is critical? Well, actually this point here, it's not a critical activities, but that dummy activity is critical, isn't it? Because we've got no slack between those two event times. 5 plus 4 is 9, and so that one is completely critical. And then we've got 9 plus 4 is 13. That one is critical. Notice these ones, F isn't critical because 9 plus 3 doesn't give us 13. Plus 3 gives us 12. So that's your check to see whether something is critical. So we had to list them. Critical activities. Are B, E and H. Right. How much longer could be spent on activity F without it affecting the overall completion time? Well, the earliest time that F can start is 9 hours. The latest time it's allowed to finish is 13. It takes 3 hours, so we could afford for it to take 4 hours and that not affect the overall completion time. So that is 1 hour extra. So all we're going to write for part 3 is 1 hour. Activity F could take 1 hour longer. Okay? You see how all we're going to do is be really careful about what the question is asking us for and answer exactly what it wants. Suppose that each activity requires 1 worker. Once an activity has been started, it must continue until it's finished. Activities cannot be shared between workers. State how many workers are needed at the busiest point in the project if each activity starts at its earliest possible time. Okay. Well, I have to admit my instinct for this. I didn't answer this in quite. I didn't arrive at this in quite the way that they wanted. My thought on this one was, at the busiest point, when do activities have to happen together? How many workers do we need on site? How does that all fit together? So my instinct here was to think that somewhere around about here, when we've got D, E going on, somewhere after say at the 6 hour point. At the 6 hour point, we've got C and D and E all happening at the same time. If they've all started at their earliest point, or round about the 6 hour point, then there we have 3 things going on. And so the question for 1 mark said how many workers? It's 3 workers. That's the only answer that we need. One thing to think about with this is you can also work out how many workers you might need. If we work out what the total of all of the activities are, then how many workers would you need to fit them in the time? So if you add up all of the activities, when we're thinking about part B, where it says, suppose that there are fewer workers available than given in your answer, explain why the project cannot now be completed in the minimum project completion time. What they were really looking here for is for you saying that the sum of all of these activities, what we've got 9 plus 4 is 13, 14, 15, 16, 17, 18, 19, 20, 24, 28. We've got 28 hours is the total activity time. If we divide that by 2 workers, which is fewer than the number here, that's 14 hours. And that's enough, isn't it? That if we divide the total of all the activities by the 2 available workers that we've got, then they would each need to be working fully occupied for 14 hours to complete all of those activities. So there's no way the whole project can happen inside 13 hours. And that's probably the neatest answer for this bit. The total time is 14 hours for each of 2 workers. So if there's only 2 workers available, the minimum it can possibly take is that it would have to take at least 14 hours. My answer when I did this kind of recall, I didn't think of doing it that way. I was talking about at a particular time, so at the 5-hour mark. If there's only 2 workers, then D would be delayed, and that would delay H or F, and that would affect the overall finishing time. So you've got to explain how your additional thing affects the overall project. The final bit said, and again I'm going to highlight something here because we missed a little bit about what the question was asking for. The question said, suppose activity C is delayed so that it starts 2 hours after its earliest possible start time, but there's no restriction on the number of workers. Describe what effect this will have on the critical activities and the minimum completion time. And so there's 2 things for you being asked to describe the effect on here. In part 5, we had a tendency to only answer one of them. So what does happen? Well, C, what we've been told, C is the one that is going to start 2 hours after its earliest possible time. So it's going to start at 7. If it starts at 7, it doesn't finish until 11. So that means that F can't now start until 11. And 11 plus 13 is 14, so F is now critical. And C is now critical, because the others now have a little bit of flexibility in them. So C and F become critical. So the critical activities, the question said state what the critical activities are, or state what effect this will have on the critical activities. So it's now B, C and F that are critical. B hasn't stopped being critical. Okay, it's still, if we've got any delay there, then that would affect this 2-hour delay on the start time of C. So they're the critical ones, and the completion time is, we've added, an extra 1, haven't we? We've added this to 14 hours, because that's starting at 7, so it's finishing at 11. 11 plus the 3 gives us 14 as being our time. It was only 2 marks, and notice what the 2 marks are asking for. They wanted the new completion time, so 14, and they wanted the list of critical activities, so B, C and F. That's what the 2 marks are for. There we go. Things to watch out for. So this was last year's D2 paper, and slightly unusual things with critical path analysis. There was, you were given the network, so something to look out for this year. Expect to have to draw the network from a precedence table, because that's the more usual way of doing things, so I think we'd revert to type with that. And there was no kind of real resource histogram, Gantt chart, cascade chart kind of things going on there. So look out for that idea of having to, it almost touched on it here with this bit of talking about the number of workers, but look for that thing we have to do a little graph. So I'll show you how the resources would be used as you go through it. There we go. And that's maths.